Greetings, everyone, and welcome to this edition of our Cisco Escape Room. Today, we're going to be focusing on routing and switching, and it is a massive escape room. In previous escape rooms, we have been very strategic with the escape room. What have we done? We have focused on specific little things one by one, resetting the topology each and every single time we do it. But today, oh no, everything's destroyed in one shot. We have to make sure that we get out of this escape room together, folks. And how are we going to accomplish that? Well, we are going to have to fix a problem. Now, there are a multitude of problems here, all right? But the ultimate goal is this. You'll see in the chat area, Dan Young. Say hi to everyone, Dan Young. All right, Dan Young has tasked me with one thing before I leave for vacation. So we have about an hour, folks. We have an hour, and I'm not joking. I'm going on vacation in 1 hour, and my family's going to leave without me if we're not out of this escape room. So Dan Young has tasked me with one thing. My CEO sits right here. My CEO sits right here. My CEO has to be able to ping 1.1.1.1. All right? That's it. If we can do that, then I get to leave. Now, what Dan has also told me, and Dan, please confirm this because somebody else is in this chat area that doesn't know this is going to happen to them. But I get to leave for vacation after this as long as we can get from here to here. And then after that, everybody, you see Russ in the chat room? If you've been in a webinar with us before, Russ is always in these chat rooms. But Russ, Dan's tasking you with fixing the rest of the network while I'm on vacation. And it has to be done by Monday morning. So you might be staying the weekend, bud. You might be staying the weekend. All right, folks. Everybody, welcome again to this webinar. Let's get started on this adventure and make sure that we can get from here all the way over to here. And our one requirement, folks, is to make sure that we use a troubleshooting methodology called following the path. That's very important when it comes to troubleshooting. Because if you just decide, I'm going to start troubleshooting anywhere, the problem is that you may be picking something out of here, picking something out of there, picking something out of there, right? But you start to lose track, you start to lose control, and then you start to actually end up double checking, triple checking, quadruple checking the same things over and over and over again because you're all over the place. So by following the path, we ensure that we start from here and verify from here to here. Verify from here to here, verify from here to here, verify from here to here when it's all said and done. And if we can do that, we should be able to ultimately get that ping done. Then we can all leave and Russ gets to stick around and solve all the rest of the problems that might arise. All right, so with that said, we are going to zoom into that part of our network right now. And first things first, folks, let's verify that the problem exists in our particular environment. So what we're going to do is we're going to go to PC1 and we are going to ping 1.1.1.1. All right. What is the reply we get in this particular case? It says here that the destination host is unreachable. Notice how it says we have 4 packets that were sent, 4 packets that were received, and 0% loss. You know, if you just looked at this right now, folks, you might conclude, based on 0% loss, that your ping was successful. But the ping was not successful. Why? Because it says destination host unreachable. However, take a look at the IP address, please. Take a look at the IP address. That is our first key here. The question is whose IP address is that? Because if we can figure out whose IP address that is, then we can get a better idea of how far we're actually making it in the network, right? So if that's like the default gateway's IP address, then we know we're getting to the default gateway. If that's the edge router's IP address, then we know we're getting to the edge router. So right now, what's the first thing we want to do? We want to check our own IP address, right? We want to check our own IP address. So let's type in ipconfig, and we'll see here that our IP address is 10.40.12.8. And that is who's responding. So we are responding to ourselves. That's what we're doing. We're responding to ourselves. That's why it's 100% success, 0% loss. Because the ping is, well, we're answering ourselves, saying destination host unreachable. All right. So if we focus now on our network, I'm not going to worry about the PC itself. All right. So this is not about troubleshooting PCs themselves, folks, or anything like that. Where would we begin our troubleshooting if we're dealing with routers and switches in this case? What is the first place we should go check in regards to our networking equipment? All right, so somebody says ping the default gateway. Sure, we can go ahead and do that. Yeah, so we go ahead and do that, ping the default gateway, and you'll see we are responding to ourselves. So we can't even get to the default gateway either. All right. Good. All right, so we now know that we can't reach 1.1.1.1 and we're answering ourselves. We can't reach the default gateway and we're answering ourselves. So definitely there's a problem that exists between here and our default gateway, which is right here. Definitely there's a problem. So if we're following the path, where's the first network device here that we should check? Let's check. No problem with phones. This is not about troubleshooting phones, so we're not going to worry about the phone either. All right. Good. So let's begin following the path. What's the first logical place? This interface right here. That's what we should go check. All right. So we're on ASW1 right now. Interface gigabit 1/0/1. Is it possible, folks, that the interface could be down? If the PC is essentially answering itself, is it possible the interface could be totally down? Right, remember, the opening scroll. If you missed the opening scroll, folks, because you weren't here on time, there was an opening scroll that told you we had this massive insider threat that unleashed chaos of bits and bytes on our network. And what happened is that it totally destroyed the whole network. Configurations were changed on me. Yeah. All right, so let's just verify if the interface is up or not. So show IP, interface brief. Woo! Not looking good on this switch right now, is it? Yikes! All right. So some of them are up. 45, 46, 47, 48. They're up. Okay, they're still up. But gigabit 1/0/1 is down. Okay. So the interface is down. Folks, if the interface is down, this one there, if the interface is down, is it possible for us? To learn the MAC address here? If your interface is down, can you learn a MAC address? No, right? Okay. So we don't even have to check the MAC address table right now, because if you're down, you can't learn MAC addresses. Always remember that. If the interface is down, it can't learn. All right. So we have to solve the reason why it's down. Now, folks, would it be down because someone shut it down with the shutdown command? Yes or no? No. Why? Why not? What would it say if it was shut down by someone? Yeah, it would say administratively down. That's what it would say instead. So we know just by looking at these outputs that it's not administratively down, meaning that it is enabled. We're just not able to right now make a connection at layer 1 or layer 2. So let's type in show IP interface gigabit 1/0/1. And it says that we are down. Right? Still, perfect. What else does it say? We have an access control list that is not set. So while we're here right now, let's make a mental note that it's not an ACL that's causing us a problem on this interface. So we're good there as well. All right. So far, so good. All right. So now, what could cause an interface to go down, folks? What could cause an interface to go down? Unplugged, air disabled. Okay. So I'm going to get Russ. Russ, can you check to make sure the cable's still plugged in? Is it plugged in? Yes. Absolutely. Cable's plugged in. So we're good there. 100%. Wonderful. Excellent. All right. So someone said air disabled. Air disabled. Really? Good. There you go. Mark says, hey, Raymond, show interface status. That is one of the best commands we can use on our access layer switches to verify the status of our interfaces. Look at that. What do you guys see? What do we all see here? Air disabled. So before we even bounce the interface, before we do anything, this is a perfect command to always check, folks. Absolutely. Perfect command. And you can see that that one is air disabled. Excellent. Now, why though? Does anybody know how we can find out exactly why? Some people don't know this command that I'm about to show you exists. Watch this. You can actually type in show interface status air disabled, and it'll tell you exactly why. Exactly why. That is awesome. Perfect, right? So we now know we have what? A port security violation. We do. So let's type in show port security, and we'll see here that gigabit 1/0/1 has a maximum secure address count of 1. Folks, how many devices are connected to this port right now? 2, right? So should that value actually be 2? It should be. Absolutely. But while we're at it, let's just see if there's any addresses in here for that interface. There are none. And lastly, let's look at the specific output for interface gigabit Ethernet 1/0/1. And the reason why there are no addresses in that table, simply because the interface is down, or it hasn't learned anything. But you'll see here for 101, it actually tells us we are in a secure shutdown state. Maximum MAC address count is 1. And we've learned more than 1 MAC address on that interface. That's why we're shut down. So now let's type in show run interface gigabit Ethernet 1/0/1. And you'll see here, folks, that it says switch port security. Well, where's the rest of the config? You always have to remember this about the running config. Default values don't show up. That's right. Default values don't show up when you type in show running config. So with that in mind, we need to realize, what are the defaults? Well, the default would be maximum 1. So what I need to do is I need to set the maximum to 2. So we'll go to interface gigabit 1/0/1. We'll type in switch port security. We'll type in maximum, and then we'll type in 2. And we'll take a look at the output of do show interface gigs 1/0/1. And we'll see now that we have a maximum set to 2. All right, so now if I type in do show interface status, you'll see that it's still error disabled. Why? Yeah, because we'll have to wait for a while for it to fix itself. No, absolutely not. Yes, that's right. We have to do what? We have to do what? We have to shut, no shut. We have to shut, no shut. Exactly. So what we're going to do is we're going to type in shut to shut down the interface. So now it's administratively disabled. Let me show you that output. Do show IP interface brief. So folks, this is what it looks like if it is shut down by an administrator. That's the difference. That's the key thing right there. All right. Now let's bring it back up. We'll type in no shut. And since we bounced the interface, our goal is to see that the interface is up. Fingers are crossed. All right, interface is now up. So what we're going to do is let's go and test connectivity now. Let's test connectivity. Every time we find a problem, let's test. So we'll try to ping our default gateway. Nah. All right, maybe I'm just impatient and it's supposed to. No, I'm not. Oh, come on. All right, so still not working. Our goal is to get to 1.1.1.1. We can't get there. All right. Shouldn't we refresh the IP address? To refresh the IP address on our PC? No, because remember, it's a DHCP lease. So we'd still have that lease. Don't have to refresh it. We're good there. Because the lease is good on this case for days. So we're still good on that. All right. So with that in mind, let's think about where we should go next in our troubleshooting. Remember, we're following the path in this particular case. So where should we go next? So checking the routing table is a good idea, but we're too early for that. Why are we too early? Because we can't even get to our default gateway yet. If we can't get to our default gateway, it means we have a problem in this part of our environment. Our problem's down here. All right, and we've already solved one problem here. So the next question is, what should we do next? Good. Yeah, you know what? Somebody's saying, let's verify our trunks, right? We have trunk links here. We should verify those. Remember, lots of things were broken here. We don't know what was broken. And if we follow the path and think about connectivity here, we need gig 101 up and running. We need connectivity. Are we learning the MAC address? Let's check that out now. Do show port security address. Look at that. We have it now. We have an address in the table, learned dynamically. And there's the phone's address. So we know that gig 101 is working properly now. So that's good, okay? So next, let's check those trunks out. That's the next best thing we can do from a connectivity standpoint. So what we're going to do, we're going to type in show interfaces trunk. So when we type in show interfaces trunk, we have those 4 interfaces that are trunks. I like that. We're using 802.1q encapsulation. I like that. We have our native VLAN 1. That's okay. Not great, but it's okay. And then we look at our allowed VLANs on our trunk, our VLANs allowed and active in the management domain, and so on and so forth. Is everybody happy here right now? Does anybody see any issues in this particular output? Oh, look at that. A few of you said 421 is not allowed. Not allowed. Really? Yeah, look at that. VLANs allowed on trunk. It says 1 through 420 and then everything else but 421. So we could look at this another way. We could type in something like show interface gigabit 1/0/45 switch port. And when I do that, we'll see that down here it says trunking VLANs enabled is 1 through 420 and 422 to 494. So the same information we saw in the output of show interfaces trunk. So the problem right now here is, notice how it says VLANs allowed and active in the management domain. 421's not showing up here either. And then down here, it's not showing up for spanning tree protocol. The thing is we have to realize that this list here is populated based on this list, which is populated based on this list. That's how this output works, if you weren't aware of that. So this list gets populated based on this list, which gets populated based on this list. So if I'm looking down here and I see something missing, then my next thing is to look up here to see if it's missing. If it is, then it's to look up here and see if it's missing. If it is, the problem is here, not here, not here. That's where my problem is when I look at this output. So when I'm going to have to fix this. So what we're going to do now is we are going to, because the PC, by the way, is in VLAN 421. All right, that's what the PC's in, 421. So we'll type in show run now, show run interface gigabit 1/0/45. And we'll see here that we have a command that says switch port trunk allowed VLAN 1, 420, 422 to 494 in this particular case. All right. So somebody says, is the VLAN created? Well, let's check that out. Let's check that out first. That's a great question. Show VLAN brief. Is it actually created? And it is. It's there. Gigabit 1/0/1 is in that particular VLAN. So we do have that VLAN, which is great. So we've confirmed that. It hasn't been deleted. It hasn't been removed by the insider. Right? But we can definitely see that our trunk port here is missing what we need. So let's go ahead and add that back in. So I'll go to our interfaces. So configure terminal, interface range, gigabit Ethernet, 1/0/45 through 48. Okay. Yes, and a few of you have already provided the commands now. So we'll type in switch port, trunk, allowed, VLANs, add. Let's add back in 421 as an example. I could type in all if I wanted to instead. Switch port trunk allowed VLAN all. Or maybe we want to just specify the exact VLANs we have. So we could say something like switch port trunk allowed VLANs 421, 422, 423, 420, which would be the recommendation. Only add the VLANs that you need to for your environment. I'll let Russ fix that later because Russ has got nothing to do. So I'll just add it back in, meaning we're going to allow all and Russ can fix things after the fact. Our goal, remember, is to get the CEO connecting up to the 1.1.1.1 address, and then everything is perfectly fine after that, and I can leave for vacation. So we'll type in show interfaces trunk now. Good old Russ, I know, right? No, it's not Russ's fault. It's not Russ's fault. It's that Russ is such a great friend to have and is willing to do anything for me. So that's awesome. Thank you, Russ. All right. So with that in mind, you can see now, folks, the VLAN's allowed on the trunk. And we have 421 now there. And look, 421's now here. It's now here. It's now here. It's now here. Now, if you notice, it's not down here. And that's typically, oh, it's there now. It's there now. Why did it take so long? Spanning tree protocol. That's all. That's all. So right now, folks, I'm not really worried about spanning tree protocol as being a problem. And the only reason why I'm not worried about it is because when I look at this output, I can see that spanning tree protocol right now is allowing 421. Now, it's kind of strange to me, though, because it shouldn't be allowing all four. There should be blocking going on here somewhere, but it could be a result of inappropriate VLAN configurations elsewhere, because spanning tree protocol trees on Cisco devices are created based on the VLANs you have, the trunks you have, and how they're configured. That affects spanning tree protocol. So in the end, I'm not going to troubleshoot spanning tree protocol just yet, because you want to troubleshoot the technologies that are mandatory for successful communication, like your VLANs, your trunks, your default gateways, and so on and so forth. And then if you still don't have the right solution you need, then going back and checking some of those other peripheral technologies like spanning tree protocol, which is running by default, it might just be selecting the wrong path at that point in time, and you can verify that after you've fixed everything else. There's no point troubleshooting spanning tree protocol if your rest of your network is not set up properly, because spanning tree protocol makes its decision based on the way the network is set up. So if I've got problems on DSW1 and DSW2 right now, that's why the spanning tree protocol is making the decision it's making. So Don't want to try to troubleshoot spanning tree protocol until I fix everything else in that layer 2 network. All right, so great. What's the next logical thing for us to do, right? The next logical thing for us to do is to check the other side of our trunk link. But wait. I'm pretty sure I still have a problem because I'm seeing all 4 VLANs in this output here, right? If it was the root bridge, right? If it was the root bridge, that makes sense. But it shouldn't be the root bridge in my environment. So let's just check that out. Show spanning tree for VLAN 421. Oh my gosh, I am the root bridge. All right, so there's definitely a lot of stuff going on with these trunk links and DSW1 because DSW1 is supposed to be the root bridge in my topology. Now, even if the cyber criminal, the insider, changed this to be the root bridge, right, we would still have connectivity when it's all said and done to the default gateway if the trunks were set up right and VLANs were set up right. That's why I'm not really worried about spanning tree protocol just yet. All right, so let's do a ping test, right? Let's go right to the default gateway because if we can get to the default gateway, then, you know, we can move on to routing and stuff like that. So there it is. All right, we're still responding to ourselves saying we can't get to the default gateway. So that really means, folks, that we don't even have the ability to get like the MAC address. Like our ARP resolution's not working. Nothing like that is working right now because we can't get to where we need to go. So yeah, somebody already mentioned we should check out the other side of the link. Absolutely. That is 100%, you know, the way you want to look at this, right? If this is set up right now, then what about this side over here? Let's check that out because there could be a problem with the configuration. So we'll go to DSW1 and we'll type in show interface. Yep, show interface trunk. Just like we did before. All right, so when I look down here, we got trunking all set up. So trunking's on. VLAN's allowed in the trunk. We're allowing all the VLANs. So far, so good. It says here that VLAN's allowed and active in the management domain. Oh, okay. All right, so what are the problems you might see here, folks? Just come into your head right away. All right, so one person said ISL encapsulation. Okay, so this side's using ISL for encapsulating our messages that are going across a trunk, which is a Cisco proprietary trunking encapsulation method. What was ASW1 using again, folks? 802.1q. So they're speaking 2 different languages. This side's speaking 802.1q, so it's doing 802.1q tagging for all the frames, but this side's using Cisco ISL. So that would be equivalent to one side speaking English, the other side speaking Spanish, as an example. So very hard to understand each other as they're speaking different languages, essentially. So that's one of our problems. We can see that right there. Does anybody else see another problem? Good, yeah, Fred. Fred says, I think Benjamin as well, Brian as well, said that in this case, we are missing on DSW1 VLAN 421. And that is 100% confirmable here. Why is that? Because it says here we're allowing all VLANs on the trunk. So there's no filtering going on like we saw with ASW1. But now as we move down here, we can see that it's actually missing in our management domain. Now, it might not be missing. It could be suspended. It could be shut down as well, the VLAN itself. So we got to verify whether the VLAN's actually missing or whether it's suspended or shut down. Where could we do that, folks? Where could we do that? Show VLAN brief. Good. Yeah, let's do that. All right, so you'll see here that the VLAN's totally missing. Totally missing, right? So let's go ahead and add that in first. So we'll type in VLAN 421. Exit out of there. Do show VLAN brief. And there we go. Now it's added back in. It'll take some time for the device to converge and do what it needs to do. So we'll just take a moment here to answer a question about, wait, what do you mean active? What do you mean active, Raymond? Well, look at the status of your VLAN. By default, it's active, right? Well, you can actually change that. Let's mess around with one of the other VLANs right now, 424. So you can actually shut down a VLAN. And by shutting down a VLAN, what that does is it ensures that no traffic is allowed to flow for that particular VLAN now. And in this case, when you just type in VLAN 424 and you type in shut down, what that does is it actually will disable that very specific VLAN. So VLAN 424, we shut it down, right? That also affects any interfaces that you have as well associated with that, right? Also, if we say no shutdown, I'll bring it back up. What we can do is we can actually suspend a VLAN. So for example, if we type in state and we type in suspend, there's active versus suspend. Then we type in do show VLAN brief. We'll see here that the wrong button. All right, we are no longer active only. So what this does is it allows you to control whether your VLAN is allowed to pass traffic or not without having to delete a VLAN or disable interfaces or anything like that. So if you ever end up in a situation, let's say VLAN 10 is under attack in your environment, instead of disabling interfaces and stuff like that, you could ultimately just disable the VLAN, suspend the VLAN, shut down the VLAN, and that ceases all traffic to flow through that device for that particular VLAN. Something to think about in your future if you ever need to take advantage of that feature of your VLANs, all right? So I'm going to go ahead and make it active again. State active. And there we go. All right, so now the rest of it should have converged properly while we were doing that little side hustle there. Okay, so VLAN 421 is now up. It's good. What else did we say? Show interface trunk. If we verify this now, we'll see that we have VLAN 421 showing up here now, which is great. All this is looking good. But like we said, the encapsulation's wrong on all of those interfaces. All right? No, Rust didn't cause the problem, folks. Rust did not cause the problem at all. At all. Maybe it was me. Just to create some excitement. Beautiful. Yeah, all right, perfect. Thank you for that. So in this case here, we want to change the encapsulation on all those interfaces. Let's just see what it looks like right now. So show interfaces, gigabit Ethernet, 1/0/ we'll pick 17 here as an example. Oops, wrong command. That was the wrong command. What do I want to take a look at? Show interfaces run. That's what I forgot to type in right now to show everyone. Show run. There we go. And without an S, there you go. Pretty picky. Switch port, trunk, encapsulation, ISL. That's why we're using ISL, because it's been typed in on that particular device. So what we're going to do is we're going to type in configure terminal, and we're going to change it on all of them right now. So interface range, gigabit Ethernet, 1/0/17 through 24. So we're going to do all of them. So we've got 17, 18, 19, 20, 21, 22, 23, 24, all of them right there. Let's change those to switch port, trunk, encapsulation, .1Q. Right, so now we're both speaking the same language on each side. Yeah, we already verified that ASW1 was using it. We already did that. We already did when we were there. We confirmed that. And we even compared it while we were talking about it. So good. Excellent. So What we have now, folks, is we should have the ability to get to our default gateway. But let's just make sure that right now we type in show interfaces trunk. What do we have? We have encapsulation.1q. We have our VLAN showing up there. We've already verified ASW1. All right. We added V21. We covered that. All right, HSRP is up now as well for 421. That's nice. So we're starting to see some activity happening on DSW1 with other protocols now that we fixed some problems. So with that in mind, let's go back to our PC and let's see if we can ping the default gateway now. Wait, is that working? Yes or no, is that working? I don't believe it. It is. Okay. That is awesome. So PC1 can ping the default gateway now. Beautiful. If we look at 1.1.1.1 though, no. Ooh, but look at the answer now, folks. Look at the answer. What does it say? Who is now telling me? Who is telling me? Okay, who is that? Who is that? Now, we said that the default gateway is using that address because if I type in IP config, right, it's 10.40.12.62. It's that address there. So 10.40.12.1 is who? It would be the interface of that default gateway. That's what it is. So on DSW1, let's type in show IP interface brief, and we'll see here that our SVI for that subnet VLAN broadcast domain is 10.40.12.1. So that is who's responding back to us. So it is DSW1 that is responding back to us saying destination host unreachable. All right. So with that in mind now, folks, have we solved so far enough problems to successfully get traffic from here to the default gateway? We have. Absolutely, we have. So what does that mean now? It means that we get to shift our attention over. Remember, our goal is this. Get that PC to be able to ping 1.1.1.1 out on the internet. That's our goal. Okay, so we got to shift our attention now over because we are through the layer 2 environment. We can get through the layer 2 environment. So we solve VLAN issues. We solve port security issues. We solve trunking issues. We're at DSW1 now. So let's move over in the topology. Now that we've moved over, let's focus here. Remember, following the path. So the first thing we want to do is check what? Routing table. Exactly. Check the routing table. And folks, what's the first thing you'd want to be looking for in this routing table if you're trying to get to the internet? A default route, a route to 0.0.0.0. Exactly. Okay, do we see anything for 0.0.0.0? No, we don't. In actuality, do we see anything beyond what is directly connected to this router? We don't see anything, do we? Okay, so this tells us what if you compare it to your topology now? If you compare it to your topology, it tells you that something is wrong with OSPF. Something is wrong with OSPF. That's what we can conclude from this. Good. Right, so somebody said, check out show IP protocols. Why? So you can immediately see if OSPF is even running. That's great. I love that. That's a great answer. Suggestion, I should say, because I didn't ask a question. That was a great suggestion. So show IP protocol says we are running OSPF here. We are. Great. And what else does it say? Well, a bunch of other stuff. What do we need to verify first and foremost with OSPF, folks? Good. Somebody says, do you have neighbors? Good. Let's check that out. All right. Show IP OSPF neighbors. Okay. No neighbors. Good one. No neighbors. All right. So then what do we need to check next? Good. Yes. People are saying check to make sure your interfaces are participating in the routing process. Awesome. Show IP OSPF interface brief. Great starting command. And what does it say? It says all 5 of these interfaces are participating in the routing process. So we have our SVIs participating in the routing process, plus this one and this one. Excellent. I like that. Okay. So let's now do what? Anybody have any suggestions? What should we do now? Well, we can check our areas. It's right there. Yeah, we're good there. Okay, think about it. If I want to share information, I want to share routes, I must have what? A neighborship. Therefore, the device on the other side needs what? It also needs to be participating in the routing process, doesn't it? Do we need OSPF running here? Do those interfaces need to be participating? Yes, absolutely. Right? Absolutely. Yeah, so right before we go any further, let's go to the other side as an example. Let's go to R1 and we'll type in show IP OSPF interface brief. Are their interfaces participating in the routing process? Yeah, they are. Look at that. They are. Okay. So here's the deal. Focus on just one at a time now. Let's focus on this one here, folks. Gig 1/0/13 to gig 00. What could possibly cause a neighborship not to form with OSPF? What could possibly cause a neighborship not to form with OSPF? Brainstorm. Let's go. Everybody. Okay, timers are one. Area ID's another. What else? Yeah, timers an area. Authentication's another. Awesome. Ooh, the mask. Wow, Mark, that is a really great answer. Yeah, the subnet mask. That is so good. Never even thought of that one today. That's a good one. OSPF, network type. Oh, those are good. MTU mismatches. Folks, you are amazing. Those are like the best answers ever that have come through like that in a brainstorming session here. Great job. Okay, let's verify those now. And the best way to do that, the simple command to do that. Show IP OSPF interface, and then you type in the interface you want to take a peek at. All right, so what do I need to do? I need to now compare and contrast DSW1 and R1. That's what I need to do. So let's go to R1 and do DSW1 and do the same thing. Show IP OSPF interface, and then it's going to be gig 1/0/13. All right, here we go. Compare and contrast. Find what you can find and let me know what's wrong. So here's DSW1. Here's R1. Here's DSW1. Here's R1. So as you're doing this, just pick something like the subnet mask, the network type, the timers. Oh, authentication, folks, would show up down here at the bottom. Right? There's no authentication there. There's no authentication there. Ooh, oh, did you know passive interface shows up in here as well? If it was passive, the interface, it would actually say it's passive right there. It would say it. Instead of saying hello do, it would tell you it's passive. Okay, so they're not passive. So this is good. Yeah, timers, right? Timers, hello of 12 on DSW1 and a hello of 10 on R1. So let's go over to DSW1 and fix that problem. Show interface, gigabit run, 1/0/13. Yeah, look at that. So we'll type in configure terminal and we'll remove that now. Oh, this is great. Good job, everyone. Okay. All right. Now, if we type in do show IP OSPF interface gigabit Ethernet 1/0/13, we'll compare. Things are looking pretty good. But wait, I still don't see a message, do you? I still don't see a message saying that we formed an OSPF neighbor adjacency. And I'm stalling enough here. I really am trying to stall. So I see neighborship formed, but nothing's coming up. What should we do now to double check if the neighborship good? Yes. Double check. Show IP OSPF neighbor. No. Well, at least we're seeing something now, right? We're seeing something, whereas before we were seeing nothing. Let's try this one over here. All right, so we're seeing something. So out gig 00, we're state X start. Out gig 1013, we're state exchange. Does anybody know what is a common reason for that to occur? MTU mismatch. Yeah, so if we type in show IP interface gigabit Ethernet 1/0/13, you'll see here the MTU is 1500 bytes. But if we go over to R1, fingers are crossed that this is the reason why, or else we're going to be troubleshooting some more. Show IP OSPF interface. Nope, show IP interface gigabit Ethernet 0/0. What do we have? Oh, MTU is 1476. There's the problem. The MTU by default must match on both sides. So we'll type in now show run interface gig 0/0, and we will change that. So we'll type in configure terminal, interface gig 00, and then we'll type in no IP MTU 1476. And we should see, it's going to take a little bit of time. It could take a minute or so. But now we are all set on R1. We should have our neighborship come up here shortly. All right. But while that's happening, let's let that cook right now. We'll let that cook. We'll just see if anything happens here. Because right now it'll be stuck. Show IP OSPF neighbor. It's kind of stuck in the init state right now. And I don't want to jump the gun and start troubleshooting more because then this one's down. So let's just give it some time. Let's give it some time and we'll see if anything sorts itself out here. But in the meantime, think about this. We still have to focus on this connection as well now. Right? I want to make sure both of these are working before I leave for vacation. So let's shift our attention over to now the connection between DSW1 and R2. We already know with the output of show IP OSPF interface brief that 14 is already participating, correct? Yeah, Neo, the default is 1500, so as soon as you change it back, it'll go, oh, there you go. See, neighborship formed. So yes, as soon as you reset the MTU back or delete the command, it goes back to 1500. Yeah. Okay, so we're good there. Now, right, let's focus on here because we've got our neighborship. Show IP OSPF neighbor, full. Go over to R1, show IP OSPF neighbor, full. Love it. So far, so good. All right, but let's now get to this. So DSW1 now, let me move R2 over to here. There's the tab for R2. So with DSW1, we know that the interface is participating. So what's the next thing we should do? Check to make sure R2 is participating, right? Because it could be as easy as it not participating in the routing process. So if we go to R2 and just type in something like show IP OSPF interface brief, that'll let us know. And there we go. Okay, so it is participating. And we're going to be focusing on gig 00. So this interface here and this interface here. Let's get that link up and running, folks. So what do we want to check here? We'll check show IP OSPF interface gigabit Ethernet 1/0/14 we said. And then we'll go over to R2, show IP OSPF interface gigabit Ethernet 0/0. So there was a question about DR and BDR. I'll talk about that later. I'll talk about that later after we're all done these trouble tickets. So if you want to hang around after and re-ask that question, no problem. I can come back and talk about that for you very quickly. Yeah, no problem at all. All right, so what do you guys see in regards to the difference between R2 and DSW1 now? What do you see? Anything stand out to you? Good. Yes, good. Excellent. All right, so someone says the timer is off again. Right. So if we type in, for example, show run interface gigabit Ethernet 1/0/14, you'll see that there's nothing here in regards to the timer. Uh-oh. Uh-oh. Why? Why is the timer different, but there is nothing about the timer here? Oh, this is an interesting one. The default timer. For what? Right? It goes back to something other people indicated, and that is the network type. OSPF behaves differently depending on the network media type. So whether it's a Ethernet environment that supports multicasting, or an Ethernet environment that doesn't support multicasting, or whether it's a point-to-point link, and so on and so forth, it will behave differently. And the non-broadcast network type was invented back in the day of wide area networking and stuff like that, where our links were very, very slow and they were often congested more than anything else. And so the timers were artificially set low for that network type. And if you notice, someone typed in this command, which changes the network type. You see, the default is broadcast. If we go over to R2, see, the default is listed of broadcast. All right, so with that in mind, folks, we want to make sure the network type matches so we don't end up with other issues like timer mismatches that could cause my neighborship not to form. So that's the one thing we got to solve. So we'll type in configure terminal here, interface gigabit Ethernet 1/0/14, and then we'll say no IP OSPF network non-broadcast. Just take it right out of there, and it'll go back to the default of being broadcast. All right. Now, also, many of you stated that we have a what problem here? A subnet mask problem. Subnet masks have to match, or OSPF won't form a neighbor adjacency. How many of you didn't know that? How many of you did not know that? Yeah, both ends of your link, they have to have the exact same subnet mask. So even though technically these IP addresses would be in the same IP addressing space, regardless of whether they're 31 or 32 in this case, OSPF doesn't like that. It doesn't like it, so it's not allowing me to form my neighborship. So as a result of that being mismatch, right, we're going to have to fix that problem. So let's go over to R2, configure terminal, interface, gigabit Ethernet, what is it? 0/0. And now we're going to type in IP address, and our IP address on this interface is 10.40, et cetera, 255, 255, 255, 252. And we should see our neighborship come up here relatively shortly. I hope. Fingers are crossed. All right, there we go. Neighborship formed. Yes. Okay. So show IP OSPF neighbor. Now, with that said, we know that we have a neighborship. So if we just go back to DSW1, let's type in show IP route. Oh, look at that. We're learning stuff. OSPF, we got a default route now. Let's go back to our PC. And we have 5 more minutes. 5 more minutes. My family's leaving in 5 minutes. All right. All right. So, with that in mind now, folks, what does this tell us? Look at the IP address. That is our reference point now. This is so valuable. So valuable, right? We know we're getting all the way to here now. We're getting all the way to here. This is so good. So good. So good. All right, so let's go to R2. Let's get there. And on R2, first thing we're going to do, folks, we're going to ping 1.1.1.1. Can we even get there? Because if we can get there, we know it's not an ISP problem. Oh, look at that. We can get there. All right, so whatever's happening locally on the device can get out. Absolutely. All right, so if we type in show IP route, we're even learning about our SVIs. We're learning about the VLAN. So that's good. It's not a routing problem. We can immediately conclude it's not a routing problem. This is good, right? Because it could be a routing problem in reverse, right? We might not be able to get back. But here I see an entry to get back. I have an entry for a default route. DSW1 can get us here. So I got to start thinking a little more creatively here. What could be a problem? Okay. Fred says NAT. Fred, did you say NAT because you saw NAT on the page? If you did, good call, right? Because network documentation is so important. So important, Fred. And you nailed that. You nailed that. Network documentation helps you stay focused. And in this case, it says NAT. So Fred's like, hey, you know what? NAT. It's possibly NAT. Let's check it out, right? So if we type in show IP NAT translations, okay, we have translations happening. We do. All right. Wow, that's a lot of translations. All right. I get it. So what's the first thing I want to do? You know what? Let's clear this. Clear IP NAT trans. Uh-oh. I think I hit spacebar too many times. As the credits roll. I love it. I love it. Oh my goodness. That's a lot. Okay, while we're here though, folks, look at the IP address. Look at the IP. That is not our PC, is it? That is not even our PC. Since it's not our PC, if I keep scrolling up, none of those are our PC. So wait, it doesn't look like that translation is working, is happening. Oh my gosh, it's not even stopping. There we go. All right. So I didn't see anything about our PC. Let's just clear that. All right, so now we got a clean slate. Let me try a ping again. All right, we're getting a response from R2. I don't think that's working properly. Nope, look at that. The asterisk means all. The asterisk is a wildcard. Oh, so clear IP NAT translation all. Clear the entire table. That's what that means. All right. Yeah, time's getting pretty close to being up. We're almost done, folks. Almost done. All right. So what's the next command we should look at for NAT? If NAT's not working, what's the command? Show IP NAT statistics. That's what we want to look at. All right, what's the first thing we want to take a look at? Well, number one, does the access list that we have for NAT actually allow us to do the translation? So if we type in show IP access list 40, it says 10.40.0.0 through 10.40.255.255. So our subnet, we said, was 10.40.23.0. 10.40.12.0. So that matches. That's going to work for us. So that successfully is allowed to translate and to interface the IP address of interface 011, and that is interface 011. Okay, so that's fine. This looks pretty good to me. What else? Anybody see anything? Russ, do you see anything, Russ, that might be out of the ordinary here? Let's test Russ. Good. Yeah, look at this. check for proper inside-outside interfaces, right? The way that NAT works, folks, is that you have to teach the device what the inside interfaces are and what the outside interfaces are. And the reason why is because it tells the router. If the traffic is arriving on the inside interface and it's leaving an outside interface, do translation. If it's coming in an outside interface and leaving an inside interface, translate it back. That's right. That's what tells the router to do it. But if it's coming in an inside interface and leaving an inside interface, don't do anything. So you have to have those correct. Look what it says, inside interfaces. Wait a second. Those aren't the right interfaces, are they, folks? Nope. So I've got to fix all of that. All right, here we go. So we'll type in configure terminal. We'll type in interface gigabit Ethernet 0/0 IP NAT inside. Interface gigabit Ethernet 0/1 IP NAT inside. And then interface fast Ethernet 0/0/0 no IP NAT inside. And then IP NAT outside. And then interface gigabit Ethernet. Nope. Interface fast Ethernet 0/1/1. No IP NAT inside. And then type in IP NAT outside. All right. We're almost there, folks. So if we type in now show IP NAT statistics, what do we have? There we go. That looks good now. Outside interfaces, inside interfaces. I like what I see right here. Things are so good. All right. Now, next, what is the last thing we want to do? What is the last thing we want to do? Well, check. Show IP NAT translations. All right. Let's issue a ping. Oh, still not working. Still not working. Has a translation happened? Yes. Okay, wait. A translation has happened for that PC. That's a good sign. That is a good sign. So, folks, if the translation is happening, that means routing has worked because NAT happens after routing. So routing has worked, NAT has worked. What then happens next? Routing works, NAT works. What's checked next? What's checked next? What do you think? What might be on those interfaces to help protect me from the big bad internet? Yes, right? An access control list is an example. So let's type in show IP interface fast Ethernet 0/0/0. We have an outgoing access list called internet access. Okay, let's check this one. An outgoing access list called internet access. All right, so let's check that out. Show access -list. So this is the one we want to look at. Are there any problems with this access list? Nice one, Dan. Deny IP host Russ. There you go. So someone, our insider, who executed their script to cause chaos, added an entry here. All right, so configure terminal. And we'll type in IP access list. It'll be internet access, so extended internet access, no 10. Done. So show access -list. And there we go. Looks good to me. Deny private IP addressing. Permit public IP addressing. Outbound, right? Outbound. So outbound outbound, deny private IPs, allow public. So that looks good to me. Okay, so let's test the PC. Wait, did it work? We're out. We got out, folks. We are successful. We have accomplished our objective of getting from here all the way over to here by solving all those problems. Oh, wonderful, folks. Right, ma'am? Now. Oh, and I missed it. 6 minutes. 6 minutes. They're gone. We didn't make it, folks. We actually didn't make it. Russ, buddy. Looks like you don't have to do anything now. You're off the hook. You're off the hook. I'm going to have to stick around now and do everything because my family's gone. We didn't make it, folks. All right, folks. All right. I want to thank each and every single one of you for being here for this wonderful adventure, this epic adventure here, folks, as we went through the multitude of issues that appeared in my environment overnight before this webinar. Thanks for participating. I had so much fun today with each and every single one of you. Just chatting in, brainstorming, having a great time. Hopefully a lot of you saw some new techniques, tactics that maybe you weren't aware of, or saw some new commands you weren't aware of. Right? That's what it's all about, these escape rooms. You just picking up a few things here or there, some light bulbs going on. And if you're already a member of the Stormwind family, I want to thank you for being part of this family, but I encourage you to continue learning. There's a lot of familiar faces here today. People who have gone through CCNA and then Encore, and they're working on an RC. I know a multitude of people, are even on other paths and other tracks, like maybe Network Plus or Security Plus, but you're interested in networking as well. So that way there you can become more valuable to yourself and your organization. And some of you are new. This is your first time experiencing something with us here at Stormwind Studios. And let me tell you, it's always about fun. It's always about learning in a multitude of various ways and not getting bored, right? We don't like to bore anyone. So please, folks, we have so many classes, whether it's cybersecurity or project management or Cisco related or A+, or ITIL related, or Linux related, right? And more. Look at our catalog. Find something that could help you or something that interests you, and let us take you to the next level of your career. We got labs, we got practice exams, we got a multitude of study resources. So you want to take advantage of everything we have to offer, folks. So we'd love to hear from you. Absolutely, we'd love to hear from you. And Colin already chatted in this link, so you don't have to click on the page, the video, which you can't. But right over there in the chat area, grab that link, folks, because that link's going to take you out to a website. And there's even a code on that website that will give you the opportunity to get a discount to join us today. So with that in mind, use that link. If you don't want to use the link, write this down. Grab the email address, grab the phone number, contact Mike. Mike's ready to help you out, but I encourage you not to delay. Don't wait. Your journey begins today. Always remember that. What you do today will pay you tomorrow. That's how it works. So start today. Don't wait. Don't delay. Make yourself more valuable and let us be part of your journey. All right. With that in mind, folks, keep on being amazing. Keep on the great work. And our webinar is officially done. So if you need to leave, please feel free to leave. But if you want to stick around and ask a few more questions, we'll stick around here for a little longer to answer some of your questions. But until next time, folks, keep on being amazing. Keep on having fun. Keep on making yourself more valuable. And thank you very much for being part of the Stormwind family, or being part of the future of Stormwind. We appreciate that. Thank you very much.